Hi guys, it's Miss Gold. Today's lesson is Module 1, Lesson 12, Relating Scale Drawings to Ratios and Rates. Your outcomes for today's lesson are students understand that a scale drawing is either the reduction or the enlargement of a two-dimensional picture. Students compare the scale drawing picture with the original picture and determine if the scale drawing is a reduction or an enlargement. Students match points and figures in one picture with points and figures in the other picture. The first thing I'd like you to do is actually to pause the video in order to complete the opening exercises. And when you are ready to go, just go ahead and unpause the video. Okay, so in your intro activity, you were asked to guess the image. In number 1, if you look very closely, it's actually a map of a subway system. So this is a reduction of a subway map. And this is a very useful thing because it's something that you could help to get around places like Washington, D.C. or New York City that have subway systems. If we take a look at image 2, we see that this is the image of a fingerprint or thumbprint that's been enlarged. And this is really what this lesson is going to be about, is simply identifying whether an image has been reduced or enlarged. So let's take a look at example 1. For the following problems, A is the actual picture and B is the scale drawing. Is the scale drawing an enlargement or a reduction of the actual picture? So if we take a look at number 1, you can see A is the original here and B is the scaled version, and it's much bigger than our original picture, so that tells us that this is an enlargement. In number 2, you can see that A, the original, is bigger than B, which is the scale drawing, and because the original is bigger, the scale drawing must be a reduction. So the key idea here is that a scale drawing is a reduced or enlarged two-dimensional drawing of an original two-dimensional drawing. Let's take a look at example 2. Derek's family took a day trip to a modern public garden. Derek looked at his map of the park that was a reduction of the map located at the garden entrance. The dots represent the placement of rare plants. The diagram below is the top view as Derek held his map while looking at the posted map. Okay, so we have Derek's map here, and we have the posted map outside the entrance here. So the first thing that I notice is that these are not oriented the same way, meaning that you can see that we have this D-shaped pathway here is actually down here and upside down. So what's going on here is that it's been rotated. So if I'm going to find what are the corresponding points of the scale drawings of the maps, in this case, corresponding points refer to points that are located on the same spot on both maps. So for example, with point A is located right here, and I see that it's where we start to come in on a walkway and then it takes a sharp right pretty close in. But you'll notice here that that doesn't happen here because the map is oriented differently, so we need to find where that does occur. If I look around here, I see here is a walkway that goes in and there's a point and then it takes a sharp turn. So this one has to refer to point A. So this R is going to be the corresponding point to point A. For point V, here is point V, and this one is on a much longer section and then takes a sharp right. And so as I look at this map, I can see that W corresponds to that. There's a long section and then a sharp right. So V corresponds to W. Point H, right here, is where two lines intersect at right angles. So the only place that that happens on this map here is right here at point P. And finally, point Y is located on this D-shaped figure. And the D-shaped figure is upside down here, and the only point on there is point N, so N must correspond to point Y. Okay, let's take a look at example 3. Celeste drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. So this one is her original drawing, and then this is the one that she drew second, and so this is going to be our scale drawing. State the coordinates of the vertices and fill in the table. So the vertices are these points as we move around it. It's basically the corners of it. So this first point is the coordinate point. Let's see, this is a 5, so 6, 7, 0. This would be 10, 11, 12, 13, so this is 13, 0. And these move straight up, so these ones are also going to have to be 7 and 13, but for the height, let's see, here's 15, 16, 17, 18. And this one is going to be 13, and it's at the same height as the other one, so 13, 18. For our scale drawing, or her second drawing, we have the coordinate points. Let's see, this one is going to be 7, 0 as well. And then this one is at 10, 0. This one is at 10, 9. And this one is at 7, 9. Okay. Now we're asked to find the height and the length of each of the drawings. So let's start with our original drawing. The height goes from 0 up to 18, so it has to have a height of 18. And the length goes from 7 to 13, so if we count over 1, 2, 3, 4, 5, 6, that has a length of 6. For our second drawing here, we have a height going from 0 to 9, so that has to be a height of 9. Then we have a length going over 1, 2, 3. So what if we want to know what is the scale factor that she has created here? So when we are trying to figure out the scale factor, what we're going to do is we're going to kind of take the same idea as unit rate, because scale factor actually is unit rate. So we're going to take our output, which in this case is the second drawing, and divide it by the first drawing. So essentially what's going on here is this is the scale, and then this is the original. Okay, so this is our output, this is our input, and that's the same thing that we learned how to calculate our M, which is unit rate, or the constant of proportionality. So in this case, we can choose either one of these to compare. Let's say we took these two. So let's focus on the height of our scale and original drawing. So our scale drawing height was 9, and our original drawing height was 18. So if we reduce this, we get 1/2. So really what that tells us is that her scale drawing is half the size of her original drawing. In this lesson, you learned that a scale drawing is a drawing in which all lengths between points or figures in the drawing are reduced or enlarged proportional to the lengths of the actual picture. A constant proportionality exists between corresponding lengths of the two images. Reduction: the lengths in the scale drawings are smaller than those in the actual object or picture. An enlargement or magnification is the length in the scale drawings are larger than those in the actual object or picture. In a one-to-one correspondence, each point in one figure corresponds to one and only one point in the second figure.